Guess who's back? You're not even going to believe this. The ARC A770 and the ARC A580, a revisit in 2024. We're doing it. And it's not what you think. Look at this. The ASRock Phantom Gaming A770. The Intel Arc A770. Intel, this is player 3 entering the game for GPUs. So the Intel Arc GPUs have had another driver update and the performance has once again improved. It's not just the driver update though, it's actually the in-Windows driver experience. Things are changing with the way the drivers work, and this is a big deal because even NVIDIA sees the writing on the wall. Remember GeForce Experience? You used to have to log into GeForce Experience. Turns out that was a strategic mistake. It's no longer required for what the GeForce Experience is logging into, and it is because the in-driver experience in Windows is so good with the Intel drivers and with the AMD drivers. Because of that, we see really amazing changes with the way that this kind of stuff works. And what the driver utility software does for you, what it promises is to take away some of the complexity of configuring games so that they work best with the highest possible graphic fidelity, good performance, but without also being a headache for you to configure. You see, it can be the difference between 35, 40 FPS and like 60, 70, 80 FPS with very little appreciable visual fidelity differences. But when we're doing apples to apples comparisons on GPUs, you can't really run an Intel Arc GPU with different settings from an AMD GPU with different settings from an NVIDIA GPU and say that they are like for like for like. But as a gamer, somebody playing games and doing stuff and just using it as like, I just want to have a reasonable gaming experience, that's maybe not how you would actually use the card. And so for somebody like me, putting something like this together, it's a little challenging because you got to talk about those things, right? Gamers Nexus did an amazing video with Tom Peterson about GPU hardware engineering, like hardware engineering the drivers, and you see that and you hear Tom Peterson talk about some of the architecture and some of the other stuff that Tom Peterson has talked about, and you look at it in the driver thing here. The software engineering team is Intel's secret weapon. Actually, the software engineering team is Intel's secret weapon across a whole bunch of verticals that Intel has. And, you know, one API and the integration and the AI side of it, and the software developers and like how organized and disciplined those teams seem to be with putting together stuff in the ARC drivers, everybody could learn from. There's stuff in the ARC drivers that have to do not just with performance, but also with reporting anomalies in the game and rendering and everything, because, well, Intel's GPU from where it is in terms of market space, it's not there. I mean, they are a distant third, but they have covered more ground in a shorter amount of time that it should give AMD and NVIDIA pause because of how much ground they've covered, how quickly. I think that if you're an executive on the outside looking in at a competing company and you're looking at what Intel is doing with their software and their software engineering, you're probably getting some ideas about how you can reorganize your own team and sort of bring everybody together and sort of get it done and do some really innovative things. Whoever has fought these battles to be able to deliver all this stuff in the Intel Arc control software has done some incredible work moving mountains to be able to do this. It still has a lot of warts, like there's still a lot of problems, but there are so many less problems than there were a year ago. Even for weird edge cases like Halo Infinite offline single player, which I pointed out last time, that was fixed like a week after I did my video. There's still a lot of weird little issues. I'm going to show you some really, really weird ones, but mostly it's okay. It's hard to do a deep dive on a whole bunch of different games with the ARC GPUs specifically. I think that a lot of other channels cover that, but some of the difficulty in really doing an apples to apples comparison, as I alluded to, can really come to the forefront if we talk about a few specific games. Let's look at Cyberpunk 2077 and Baldur's Gate 3 because those are interesting. So if we look at the A770, okay, Baldur's Gate wasn't out when the A770 launched, but if we look at December 2023 with Baldur's Gate versus the April 2024 Baldur's Gate performance, it is dramatically way better, with our average frame rate being 89 FPS. And how we test Baldur's Gate, because it doesn't have a built-in thing, is we go through the city in Act 3, and there's all kinds of, like, the performance in the city area, depending on the version of the game and so on and so forth. This is the April 2024 version of the game. It's pretty demanding on the system, and the 0.1% lows go all the way down to 23 FPS. But between 10 to 75, the spread from the December 2023 drivers, this is a really, really good improvement, and just like the feel of using it is so much better. And this is not even using FSR or XESS or anything like that. This is just testing on our 14900K with fast DDR5 memory. It's very good. Cyberpunk 2077, it feels like you're playing on a different class of card. From the launch drivers to, at 27 to 52 FPS average, to 60 to now 80 FPS average. But our 1% lows at 59 FPS in Cyberpunk 2077 is very, very good. That is a dramatic improvement for April 2024. And like I say, it doesn't feel like you're playing on the same class of card. Some of this is actually down to updates in Cyberpunk 2077. This test does not account for improvements in the game itself. We didn't roll back to the February 2023 drivers with the, February 2023 version of Cyberpunk, or like those numbers of the February 2023 version of Cyberpunk. Now, for 1080p, Shadow of the Tomb Raider, Borderlands 3, and Horizon Zero Dawn. This is kind of the spread here, because Shadow of the Tomb Raider, not a lot has changed in that game since December of 2022. Very little. A few little things, but not a lot. And that you can see in the drivers. And this tells a really interesting story. So from 127 to 133 FPS, big deal. Don't really see a lot of improvement there. But then you look at the 1% lows, and that tells you a very, very different story. 71 FPS for our 0.1% lows in the new and improved April 2024 drivers. This is something that feels like the Intel driver team has moved mountains in order to be able to accomplish this, and yay, go team. Good job, software engineering. Similarly with Borderlands 3, an ancient title, launch day drivers, December 2022, lackluster performance. It was fixed by February of 2023, just a few months later, but the 1% lows still not great. But with the April 2024 drivers, 62 FPS for our 0.1% lows, 97 FPS for our 1% lows to 118 FPS. That feels a lot better. For Borderlands 3 specifically, like just playing the game with the older drivers, I really didn't feel the 0.1% lows. Like, it wasn't as noticeable in Borderlands 3, just actual everyday usage, but it still is a pretty good improvement that shows up in the benchmarks. Now, Horizon Zero Dawn, on the other hand, that one you can really feel. Like, whatever has changed from February 2023 to April 2024, way different feeling. And this is one where we can use the new version of the game with the older version of the drivers without too much headache. Mostly it's okay. There is some menu glitching, but mostly it's okay. So that's the Intel Arc A770. What about the A580? Well, things have improved pretty dramatically for the A580 as well. The 0.1% lows in Baldur's Gate 3 at 1080p, down to 10 FPS in that city scene with an average of 76. You can feel it, but it's pretty good. I would probably fiddle with the settings here until I could get the 0.1% lows just a little higher, like the experience in the city, but that might just be where I experienced it on the A770. If I had an experience on the A770, I might have been okay with this. Maybe some XESS would fix this up here. Assassin's Creed Mirage, taking a look at that, 57 FPS average with 27 frames per second for our 1% lows versus 47 for our 0.1% lows and 78 Yeah, you can feel that the A770 is a different class of card, but I think Assassin's Creed Mirage at ultra high is still playable at 1080p, although I'll probably turn the graphics settings down. For Cyberpunk 2077, I think this is an anomalous result because the A580 should be worse or the A770 should be better. There's really not a lot of real world performance difference between the A770 and the A580 at high settings for these two Intel GPUs. Taking a quick look at Shadow of the Tomb Raider, Borderlands 3, and Horizon Zero Dawn for that whole A580 versus A770 comparison. And again, there's really not a huge difference at 1080p between the A580 and the A770 for Shadow of the Tomb Raider. For Borderlands 3, on the other hand, there's a pretty big difference. In playing Borderlands 3, you can feel a big difference between the A580 and the A770. Horizon Zero Dawn, playing the game, you really can't feel a huge difference between the A580 and the A770, which suggests that the A770 has more untapped headroom in this title, so more room for driver optimizations. In pretty much every game, one of the big advantages of the Intel GPU is AMD's FSR3 technology. Now, Intel has their own XeSS, which is quite good, and the graphical fidelity of XeSS a lot of times gives FSR a run for its money. But FSR3 is the latest and greatest and is a pretty big improvement. Forspoken specifically, I think has interesting results. So if you turn on FSR3 Ultra Performance with FrameGen on, you can do 108 FPS versus the baseline, no upscaling, nothing going on with the GPU, 48 FPS. And then I just tried experimenting with different settings in the menu for XeSS quality, balanced performance, FSR3 with FrameGen on, and you really, until you get to FSR3 balanced and performance, you really unlock some significant performance bumps here. I mean, to go from 70 FPS to 100 FPS, basically between quality and balanced, that seems like something is not right there to have that big of a jump. I would like a solid 60 from Forspoken, and it looks like FSR3 balance with FrameGen on is probably the thing that I would run with here in Forspoken. Now, Starfield at 1080p ultra high on the A770 in the residential district, it is not a fabulous play experience. Runs better at lower graphical fidelity settings, and with no upscaling technology, it is not playable. FSR3 with FrameGen off at about 35 FPS, it's still like, none of these numbers are really good. And even with FSR3 on and FrameGen on, it still doesn't feel exactly right, but it does feel pretty playable at those settings. I don't know that I would play at any other settings here. You can also get this weird thing where when you bring up the menu and don't change anything and then you close the menu, that the game mysteriously runs at half frame rate. And I don't know, like, that's just a glitch. Like, that's just a glitch or a bug or something. Like, mysteriously your frame rate is just half what it should be. In Intel's driver, there are places to report things like that, and you definitely absolutely should, especially if it's reproducible, and it is pretty reproducible in Starfield. In putting things together, playing a whole bunch of different games, including a whole bunch of games you didn't see for this video, I still encountered a fairly high amount of stuff like that. And this really feels like where AMD was with their drivers about 3 years ago. But again, Intel's software engineering team feels like they've got it a lot more together, especially if you look on GitHub and the code and everything that Intel has exposed. I mean, what Intel is doing with their cards and the fact that they've enabled SR-IOV on their integrated GPUs, their iGPUs, it looks like they're gearing up to do some SR-IOV stuff on the A770 without crazy people unlocking it. It looks like that the SR-IOV performance of like the Flex 170, which is, basically, but in a slightly different physical form factor, the fact that Intel GPUs work as well as they do with FSR3, like AMD plus Intel is like the winning formula here. Like FSR3 in a lot of experiences as a practical matter is a better experience than XeSS in terms of the performance that it delivers. I mean, that certainly wasn't true with the first release of FSR. XeSS appeared on the scene and it was surprisingly far ahead for a 1.0. And XeSS is still amazingly good and has had a lot of updates and a lot of improvements over time. But Intel has got to look at what the competitors are doing. I mean, NVIDIA certainly has had similar improvements with like their upscaling technology, and the stuff that they're doing is very innovative and very impressive, and especially on like the ray tracing side and all that kind of stuff. So there's a lot of layers here to this onion, but Intel has been relentless with the drivers and the performance improvement. And I was so impressed by this, just like the day-to-day usage of this stuff, that I wanted to share. Now, I've also had a system running an Intel GPU continuously for the last 6 months. And another wart that I'll point out in Intel's software approach here is that I get the feeling that Windows Update, like Microsoft and Windows Update, and how the ARC GPU drivers are updated with the software utility do not always mesh, because I would say that it's more often the case than not that when Windows Update installs an update, that the video driver will crash in weird ways, especially if I haven't rebooted my machine in an age. So like if the test machine is on and doing stuff and everything is fine, the first time I noticed it, I walked by the machine and I know it's got multiple monitors. I noticed only the primary monitor was working. And then in Device Manager, it was showing code 43 for the device, which is weird because code 43 is usually something you see on a virtual machine, but this was actually on bare metal. And this was just, okay, I have to reboot because something installed a driver update for the video driver and the driver crashed and now it doesn't support multiple monitors. And that is not something I have ever experienced on any other driver on bare metal, but it's certainly something that I've experienced when running a virtualized GPU or a physical GPU that's passed through to a virtual machine. But I'm not doing that on the machine that's in question. So I don't know. But Intel is putting a lot of stuff in their driver to say, hey, user, help us debug this stuff that we have, because we don't have a ton of, machines doing every different combination of every different set of games and every different set of tests. So if you play an obscure game and you need support and you need everything else, it may be a little problematic with that Intel GPU, but it might also be fine. And the Intel GPUs are super inexpensive. I mean, for this level of performance, for the cost they are you willing to help test? Willing to help beta test? Willing to help put up with some stuff? They're surprisingly good for what they are, especially the 580 with some of those performances. I would personally rather have the A770 16 gig, but that A580 really does hold its own in a lot of cases. And I hope you did too. I'm Wendell, this is Level 1. I'm signing out, and you can find me in the Level 1 forums.